Welcome again. Today we are going to study static routing or static routing and how to implement it on IP network. So as we said in the last lesson, static routing is manually configured on the routers and the best path is manually configured. So we're going to take this lab example and we assuming that this network is requested by a bank so that an ICT engineer was given a contract to design a network that connects the two branches of a bank of a local international bank. So one branch is located in this city called Bosaso, and the other side is located on this city called Xmayo. So the connection between them is a wide area network. We are not going to say anything about it because we are going to discuss it in an upcoming chapter. So maybe you can assume this is because this connection, these two cities are very far from each other, so that you can assume this link is maybe an optical fiber, or it may be a satellite, or it could be a microwave. So we are not going to say anything further. So this is the most important thing. Is on this processor we have our network. We have one computer that is used by an accountant, and we have also another accountant. So we at the end of the design, this accountant should be able to send the traffic, maybe financial report to his bureau accountant in the different branch. So how many networks do we have in this lab? We said when we are talking about router, every interface is a separate network. So on this router processor, we have network here and network there. And Xmayo, we have network here and network there. Because these two routers are connected, this is going to be one network. So overall, we have three networks in this case. That's why we have assigned three network addresses to configure the IP addresses on the devices. This is a representation of how your implementation is going to look like on a real rack. So on top you have the power distribution unit, then you have the two routers and the two switches, and they are connected using, for example, the two routers connected using a crossover cable, and each router is connected to his respective switch using a straight through cable. So let's start. So this is going to be when talk about static routing, this is the only command we need. So with IP route, then we type the destination network, then destination mask, and the next stop. For example, this accountant here, he knows this network, and to go out of his network, he needs default gateway, which is Kismaya router. But the problem is at this time, my router only knows directly connected networks. He knows this network and this network, but he does not know this network, which is this remote network. So if we look now the routing table of this router Xmayo, we are not going to see this network. So we have to teach him using, for example, in this case, static routing. So when we are here, when we are configuring a static router on this router, the destination network is going to be this one, and it is separate mask. While when we are in this processor, the destination network in this command is going to be this network on the right side. So having said that, let's now start the lab using packet tracer. So what I have done is that I have added some few devices and renamed some of them. So on this network, instead of the accountant, we have the ICT admin, and we have also added servers because on this network we need some service like DNS or DHCP or mail server or web service. We need some kind of a server on our network. We are going to see how to implement those servers when we go to server client administration Windows server. So on this right side, we have the finance department and we have two accountants, Ali and Jama. We have given them a name. So I slightly modified the network, but the network addresses and the number of devices are the same. This is how we are going to design it on a packet tracer. You are going to go to devices and then grab some routers. In this case, we need only two. You put them here, you place them here, and then two switches, and then the any devices. The next step is, before we go even to start routing, is to assign IP addresses on the devices so that they can come alive and be able to communicate. Without an IP address assignment, the static router is not going to function. So what I like to do is that even in the real world, instead of going to the room and connecting console cable to the router, because this room is there are air conditioners, it's very cold, I don't want to go there. What I would like is that I assign an IB. I have an ICT engineer here, and every time I need to do something, I need to telnet and remote manage all my devices. So that's what I'm going to do. And before I do that, because the routers are new, there are no configurations, as you can see, the interface are down. What I'm going to do is that I'm going to configure and bring out up those interfaces. So let me go to Bosaso, and I'm assuming right now I'm connected. In real life, I'm connected to local console using a laptop, because this is a Cisco packet tracer. You can just click on the device. So I'm going to go in this wizard. When you first boot your device, you will see this type of message. Will you like to enter the initial configuration? And then you say no, because you know what you're doing. So the first thing, we need to edit the host name. This router is going to be Bosaso. So I go to global configuration mode and I type host name Bosaso. We have seen how to do this in our previous basic router configuration. So now I have set it, and now it took effect, the name. So the next step is to configure the interface. Before you configure the interface, it's good practice to first see the status of the interface. So you type show IP interface brief, and then you take a look the status of your interfaces. As you can see in this router, I have 3 gigabit ports. All of them, they have no IP address assigned, and all of them, they are down. Right now I need only 2. One is going to my local network and one is connected to the reboot router Xmayo. So I need gigabit 00 and gigabit 01. So gigabit 00, I'm going to give this network address. Gigabit 00 is this network address 50.96. So let me configure that interface first. So interface gigabit 0/0. So the network address is slot 96. The first usable IP address is slot 97. I'm going to give it here, and 98 later here. IP address 192.168.50.97. The subnet is /27. /27 is 224. We have seen that how to find it in our subnetting class. So now you have only assigned an IP address, which is good, but they are down. So please enable them. No shot. Now if we now see the stats again, show IP interface brief. Now you see this interface is IP address is assigned and physically it is up, but protocol is down. The protocol is down. It means is that this interface is down protocol because the other end is down. So when we enable this end, the link, this one protocol is going to be up. So let me go again to this interface, go into my ICT admin or this network, and this is the network address. I'm going to assign 50.1. Again, I'm going to config the interface gigabit 0/1, IP address 192.168.50.1, and subnet mask is 255/26 is .192. Enable it, no shot, and it is, you see, went to green, from red to green. Now let me see again my interfaces, show IP interface brief. So next time I don't want to come back again to equipment room and connect a console. I want to remote manage. So let me set up Telnet, which is the most common remote management, even though it's not secure. Let me configure that. So underline VTY 0 to 15, the highest privilege. Then I'm going to local using local database. Your local username and password is stored on my router. So let me create that username and password. Let me say Java. And this guy has the highest privilege because he's the ICT admin. The password, I'm going to make it encrypted and I'm going to make it Cisco. I'm also assigned the enable password to go to the privilege mode. So I'm going to also encrypt this one. Now the telnet now is configured. Let me see, show running config. As you can see, now the enable password is given. The host and the host name is given, assigned it. And okay, we also have the interface is assigned and the line v2 I configure. Now I should be able to telnet this router from my ICT admin. Before I do that, I have to assign also IP address here. Dot one has been used by both by this interface. The next one is dot two. I'm going to assign it here. It's already assigned and the subnet mask and the gateway. The gateway is the interface, the router interface I am connected to, because that is going to be my gate to exit and reach other networks, as we are going to see. And I think also this server is configured. The server is not right now important, it only the PC is important. So let me see if I can telnet to my router or my gateway, which is Bosaso in this case. It's good to see Bosaso, yes. Before can I reach it? 192.168.50.1. So you are going to see if you can reach using Bing. So we are going to wait a few seconds. Sometimes because the traffic is going through the switch is going to use an ARP and land the MAC address of the devices, so it's going to make a delay. As you can see, we are going to get a reply at the end of the day and we can reach the gateway. So let's see if we can telnet to process router 192.168.50.1. So I can now, yes, I can now telnet remote. I can manage this device remotely. Okay, I will come back to it later. Let's do the same on this router XMAIO. We have two interfaces, gigabit 00 going to Bosaso. So .97 was used here. .98 is going to be assigned to gigabit 00. So I will say no. Enable conft. First, let me change the name. Then interface gigabit 0/0. IP address 192.168.50.98.255.255.255./27 is 224 and then no shot. Now because the other end was already enabled, once we enable this one the link is going to be up. Then we are remaining with this link gigabit 0/1 and this link is going to be this network.144. Let me do that gigabit/1. IP address 192.168.50. The first usable IP address is .145 and the subnet is 225.225. The last one is going to be /28 is 240. And then I will say no shot. Everything is now good. Now let me enable telnet. Line VTY 0/0 15 login local exit username Jama privilege 15 secret Cisco. Also I want to enable secret Cisco. So everything now is good. Let me now check the interfaces and how they are behaving. Show IP interface brief, and as you can see we have two interfaces, IP address assigned physically up, and they can now communicate using any protocol that is assigned. Or this is layer 2, this protocol is up, so that means you can send Ethernet traffic over the link or IP traffic over the link. Okay, so let me see, so right now everything configured. Let me see if this computer has an IP address. Yes, it has an IP address and a default gateway. Now let me go to static routing. Before we go, let us just see if this ICT admin can reach JAMA, and also let's inspect the routing table of each router. So I'm going to pop up the command line of the ICT admin, and I'm going to ping JAMA. JAMA right now has, if you now look it, yes, he has IP.146. So I'm going to say ping 192.168.50.146. Let me see. Destination host unreachable. So I cannot reach that destination IP address with JAMA. It's unreachable. Who is sending this message? Why am I receiving? I'm receiving from my default gateway. As this traffic leaves ICT and reaches the default gateway, This router, the first thing he's going to do is that he's going to inspect it and look at his routing table, and if he tries to find this network that the traffic is destined to. Right now, let me see the routing table of, so we can remove telnet. We can telnet to Cisco. Let me say show IP route. This is the command you're going to use to see the routing table. As you can see right now, for Sasso, we only know we how to reach these two networks C and C, .0 and .96, because they are directly connected on my local interfaces. So if, for example, you want to reach any of these two networks, I can help you, but if you want to reach .144, I can't because it's not in my routing table. So routers, they don't assume anything, they just still look at the routing tables, and they are very polite, and they say, man, if I don't have that network included in my routing table, so I can't load. So this router is going to send it back destination host unreachable to the device. Right now, so we see we cannot reach that one. So let's configure static route so that this PC is going to reach at the end the finance department. So let me go to global configuration mode, and you know the command. It's right here. IP route, not destination network. So when I'm in Bosaso, what am I going to learn? I know .0, I know .96, but I don't know .144. So this is the destination network and destination subnet mask. So let me do that. IP route question mark destination network 192.168.50.144, and the subnet mask is 255.255.240. Now, why am I going to send any traffic that's going to this destination network? Why am I going to send? I have to know the next interface, the exit place. So on this interface, I have two options. I can say, because right now I'm in Bosa, so I can say to reach this network, exit my local interface. So, but the best is that you say exit the next hub that is that is on the side of the destination. I mean, this router Xmayo is closer to this remote network than Bosaso. So Bosaso is going to say that because you are closer, I'm going to use you as my next hub. So this guy sends traffic destined here, and the gateway will send this one here based on this command. So I'm going to put the next hop, the IP address of Xmayo interface gigabit 0/0. If you remember, it was .98. So I'm going to place it here 192.168.50.98, and now it has taken an effect. Let's see. Before, previously, when we said show IP route, we only had .0 and .96. Now let's see what we have. Sometimes you can run show when you are even in any mode using do show IP route. Now you see we have another new entry in our routing table, and it is marked S. If you look this code, this S, it stands for static route. So this means this entry is learned using static route. What did I learn? I learned how to reach this destination network and to forward any traffic that's going to this network. I know where I can send that traffic to. So that's the main concept. So right now, let's see if this PC can now reach, because let's see if the ICT admin can again reach this network .144, because right now we have added this network to the routing table of this router. So I'm going to go here and say right now again ping. Let me first go out of the router CLI exit and go to my computer. So let me try to ping it. So it's not working. Still the ICT admin cannot reach the other enemy, or like this computer Java. Still he cannot reach it. So what could be the issue? The issue is, the traffic is a two-way. So if when this guy sends this traffic towards this network, now the router looks at the routing table, because we have added a static route help me in this router where to forward that traffic. If forwards, it reaches here, but the return traffic is going to fail when it reaches here. Smile. So the return traffic say that, okay, I have received your traffic. Now I want to give you a reply, go into this destination, but this destination network is missing on the routing table of this one. So this router is going to drop that traffic. So the forward traffic is going to reach the right place, but the return traffic is going to fail here at Smile. So let's add a static route also on the Smile route to teach him this remote destination network 50.0. So I still am going to go to remote management. Can I ping this? First of all, can I reach this Xmayo which has .98? I think I can reach. Let me see. Let me wait a few seconds because of our switch lining. So I cannot reach. So let me take a console cable and go to the room and then connect it directly to router Xmayo. That I can add that route. So I say IP route. So when I'm Xmayo, what is the destination network I wanted to add to my routing table? It is 50.0, this one, which I'm not connected to. 192.168.50.0. The subnet is /26, which is in full form 255.255.255.192. So yes, sorry. Now you have to specify the next hop. Why any traffic that is going to this remote network? Why are you going to send it to? I'm going to send it to this interface, which is closer to the destination network because this guy is much closer than I am. So this interface was .97, 192.168.50.97. Now let me see my routing table, show IP route. I can see now I know how to reach that network using a static route. Now let me see if this guy can now ping the JAMA, which is on the other side. It was .146. As you can see right now, we can reach because we know how to. This means like this. When I'm reaching this network, I'm going to forward to send the traffic to my default gateway. The default gateway looks his routing table and say, okay, I know this remote network. Then he's and way to set to forward it to. So he forwards it to this interface. So this guy says, okay, thank you. He looks at his routing table and he says, okay, the network that you wanted to reach is connected to my local interface. So he forwards the traffic. Now the return traffic comes to comes to default gateway. Then this router looks if he knows this network, this routing table. Once he finds that, which in this case because we configured it, then he sends it to next hop, and the next hop says, okay, you know what? The network that you want to reach is directly connected on my interface, so I can take care of that. Then the traffic returns safely and so. Let's now see if I can remotely manage Xmayo because I can now do it in here. Let me see if I can remote manage in here Xmayo. So I'm going to come to command prompt and say that I want to tell it to Xmayo. I can ping it. Can I tell it to? Yes, now I can remotely manage Xmayo as you can see. So that's how static routing is really works. That is an advantage. You know, static routing is so simple, just this one command, but it has one big disadvantage. I think it's two disadvantages I can say. One of them is that right now in this network we have only two routers, and you know how much time we spent configuring those static entries. Imagine you have 10 routers, 15 routers, 20 routers on your enterprise, and to configure one by one is time consuming. So that's one big disadvantage of a static router. The other one is that if we had a redundancy route, another link here, for example, there's another router here connected to also Xmayo, because we have statically configured this to be the best path to reach this network. If this link fails, then the whole network fails. Again, I have to come to the side and configure manually this to be the static route again. So this is also another disadvantage because we have to make intervention to the network every time a link fails. So when you want to afford those two cases, when your network is large and when you want to have redundancy paths, it's best to avoid static route. But static route, there is one special way it is very helpful, and I'm going to show you that right now. Static routing, it is really very helpful in a special case, and that special case is called a default route. So whenever your company is going to connect it to the internet, something is going to happen. So because this is my company local area network, the enterprise network, and I have a gateway router that is going to the internet. So what's going to happen is that if users in my network wanted to reach the internet, so what's going to happen? We have to do static routing on this router, and the router is on the ISP. So what's going to happen is that on the internet, my users wanted to reach a lot of websites, a lot of IP service. They want to reach Gmail, they want to reach YouTube, they want to reach millions of websites, they want to download millions of applications. So what's going to happen is that, on the internet we have millions of IP addresses, millions, thousands of networks. So what's going to happen is that if I want to use static route on the link going to the ISP, what I'm going to do is that I need to add all those networks on the internet on my router so that it knows, and I'm going to use the next hop as the router I'm connected on the ISP side. But still I have to add all those networks on the internet onto the routing table of my router. Is that going to be possible? No, because I have to add 1 million routes, because on the internet we have 1 million IP addresses, for example. So there is a special route, static route called default route, that simplifies that much. It's the same concept as a native VLAN we have seen in layer 2 networking. So the native VLAN was used by trunks to carry traffic that was untagged. So if you connect your local switch at traffic that is untagged, for example, internet, and you wanted that connect that internet to another remote site. So what you are going to do in that case was that the traffic was carried on the trunk link by native VLAN. This is the same concept, for example, because we cannot really learn all those IP addresses and we cannot add it on the routing table. We are going to send to simplify that thing much. So the default route is going to say that, you know what? If you wanted to reach anything on the internet, just use this simple command: IB route 4 zeros, then the next hop, which is going to be your ISP. So what this says is that if you want to reach any destination network, 000 means all networks on the internet, any network on the internet, not specific. So it could be 8888, it could be any IP address which has any separate mask. If you want to really, if you are sending the traffic to any IP address or network on the internet, please, you know where to send that traffic to, which is going to be my ISP. So that special route which uses all 00 is called a default route, and it is one of the most important applications of a static route. So this is also helpful when you have one connection between your company and the ISP. Sometimes if you have very many different connections, of course the default route is not going to be good. You are going to be using a BGP because you wanted to do something called traffic engineering, and you wanted to distribute your traffic across those links. In case one link fails, you still have some backups. But most companies, enterprises, more medium-sized enterprises, they have got one connection towards ISP, and they have got one connection towards another ISP. So you will not find two connections going to single ISP, because even this single ISP can fail. So still, that's why the default route still is used in today's networks. So this command means that for you, if a user wants to reach any IP address on the internet, this gateway is going to send that one to the ISP. So the ISP will understand it, and then it's going to take that traffic towards any website on the internet. So let's configure that and then wrap up this lesson. So let me go to, as I said, I like to remotely manage my routers every time. I don't want to console them. So let me go to, I'm already on Smio, it's fine. So let me say conft. Now first let me say show IP route and see my routing table before I do anything. As you can see, I know only one route that's lined through static route. So let me enable default route. IP routes all networks on the internet, or maybe all networks. For example, it's also used when you have connection with another enterprise which is using, for example, a different network than yours. So for you to learn all their networks and for them to learn all your networks, you are going to run default route. So which has any subnet mask. Why am I going to forward? I'm going to forward your ISP. So right now I'm on Smayo. I will assume that because right now we don't have internet, we are using packet tracer. We don't have real network. So in case if you have real network and you can forward it to your ISP. So assuming that Bosaso is now my ISP, I'm going to forward it to that IP address, which was .97, 192.168.50.97. So I'm going to say enter. Now let me verify my routing table one more time. Now already previously we had one S, now we have two S, but this S has a special star, as you can see. If you now look at this code here, S is static and the star is indicated as default route. So this route is at default. Whenever you see S and star on routing table of the router, it means this is going to be default route. So this means that, okay, I know how to reach all these networks in my routing table, all of these. But anything apart from that, anything that's not on my routing table, if there is a traffic going to, I know I will send that traffic to the default route. I will use the default route to forward that traffic to this IP address, which is the ISP. We are not going to use a default route on this network because these networks, we know them. They are on the routing table. The default route is used anything that's missing from the routing table. If, for example, I want to send the traffic, for example, I'm on Xmayo on this router. If this user wanted to send the traffic to network 8.8.8.0/24, is it included in the routing table of this? No, so it's going to be sent towards the default route. So that's the most common application is of the default route. And we are going to wrap up the lesson here. I think we have learned a lot on how to do a static route and how to do a default route. In the next lesson, we are going to start OSPF, which is the most used dynamic routing protocol in the world. Thank you.